In this lesson, we're going to go over some circle vocabulary and then work central angles and arcs. The first thing you need to know is the definition of a circle. A circle is a set of all points that are equidistant from a given point called the center of the circle. In this example, if I wanted to name this circle, I would call it Circle C. The symbol is simply a circle with a dot in the middle, and you always name it by whatever the center's point is. Chords. All of these examples in this picture are all chords. They all have endpoints that are on the circle. A radius is the distance from the center to any point that is on the circle. All circles have infinite amount of radii. The diameter goes all the way across and through the center. It's also known as the longest chord. A formula that we come across is radius is equal to half the diameter, or going the other direction, we could say that a diameter is equal to 2 times our radius. Take the time to pause the video and try to work through these problems. How did you do? Did you get them correct? Do you understand how we got these numbers? If not, make sure you ask me in class. Take the time to copy this example down. Pause the video and then see if you got these right, true or false. Keep in mind that on problem 3, QT is a chord because its endpoints are on the circle. Remember, that diameter is called the longest chord. A secant line intersects a circle at exactly 2 points. A tangent line intersects a circle only 1 time. Later in this unit, we'll do some problems where we'll work with a radius that is perpendicular to a tangent line. That point where they touch is called the point of tangency. See if you pause the video and can describe each one of these segments and lines. Now let's take a look at the second part of our notes, central angles. Anytime we have a central angle, the vertex is going to be at the center of the circle. You can think of the hands of a clock. The hands of a clock always form a central angle. Here's an example of a central angle. But in this picture, what we're going to work on are the 3 types of arcs. In our 3 types of arcs, we have first minor arcs. Minor arcs are less than 180 degrees. You only need 2 letters to name the arc. You're going to use where the central angle intercepts it. You put a little arc symbol over the top. It kind of looks like a frowny face or an umbrella. The other type of arc in this picture right now is major arc. Major arc, you need 3 letters. They are more than 180 degrees. And you name the letters in the order that, like Stickman would need to run around the circle, starting on one of the ones that touch the angle, and then he has to go through a middle one and then to another end point. There's one more type of arc that's not in this picture, so I will need another picture, and that's the semicircle. Semicircles represent half of the circle. You always need 3 letters, and Stickman needs to run around in that particular order. When we work some of these problems where we're going to find missing angles and missing arc amounts, there's some things that you need to keep in the back of your mind that you already remember. That all the way around the circle is 360 degrees. A semicircle is half of a circle, which is 180 degrees, and vertical angles are equal to each other. These 3 items kind of get you unstuck on some of the harder problems. Write down this formula. The measure of an arc is equal to the measure of a central angle. We're going to practice some problems and see how you do. Copy this one down. Find the measure of arc AB. This one's the easiest. It just represents the formula that you were just shown. The measure of the arc is equal to the measure of the angle. Now I need arc ACB. That's all the way around the circle except for the 96. So you could say 360 minus 96. Now I need AE. Well, E to B is a diameter, so that's half the circle. So what's 180 minus 96? So copy this one down and let's see how you do. AC is a diameter. We're going to find the measure of DAB. DAB We're going to go around the circle. Now I'm missing an amount here, so we can find the missing one by adding these up and subtracting from 360. Or there's another way to work the problem. To get DAB, we can take 40 and 80, which gives us 120, and subtract that from 360. BCA. Remember, Stickman needs to run the race. So he starts at B, runs to C, and then runs around to A. So BCA is 360 minus 100. Or you could have added these other ones. So sometimes it's easier to add, sometimes it's easier to subtract to get your answer. All right, congruent arcs have the same measure and must come from the same circle or from congruent circles. So in this picture, if I know that these angles are the same and they're both central angles, then I know the arcs would be the same. If I have two different circles, but the radius has been marked the same in both, then I would know that these arcs could possibly be the same. It would not be possible in this particular picture to show that these are congruent. They are not, because the radius is not the same.